What happens when a rock traveling from the depths of the cosmos, from a place so distant that we cannot even imagine it, decides to change its course in the void of space? Stay until the end, because what you are about to hear could transform the way you look at the night sky. This story begins with an image, a simple photograph taken from a backyard in Chicago, and ends with a question that keeps the most brilliant astronomers on the planet awake at night.
Friends, welcome once again to this space where the universe tells us its secrets. I am Felipe Suarez, and today I want to ask you a direct question, one that you have probably never considered. Did you ever imagine that an amateur, someone like you or like me, could detect something that has the entire international scientific community on alert? Because that is exactly what happened just a few weeks ago. A modest telescope, operated from the heart of an American city, captured something extraordinary. Are you ready to learn the details?
The night of the discovery was cold, as March nights tend to be in northern Illinois. The sky over Chicago had cleared after several days of dense clouds, and an amateur astronomer named Robert Chen decided it was the perfect moment to point his telescope toward the stars. Robert is not a professional scientist. He works as an engineer at a telecommunications company. He is 52 years old, and he has spent more than 3 decades observing the cosmos from his backyard. His equipment is not the most sophisticated in the world, but it is sufficient. A reflecting telescope with a 30-centimeter aperture, a specialized camera for astrophotography, and an infinite patience that only true lovers of the sky can understand. That night, Robert was looking for something specific. He had read about an interstellar object that professional observatories were tracking, a cosmic visitor designated 3I Atlas that had entered our solar system from some unknown point in the galaxy. Reports indicated that the object was gaining brightness as it approached the sun, and Robert wanted to try to capture it with his own equipment. He did not expect to discover anything new. He simply wanted to be part of history, to have his own photograph of this interstellar traveler. What he found, however, was much more than he ever would have imagined. After several hours of exposure, after carefully stacking dozens of images to reduce noise and increase definition, Robert noticed something strange in his photographs. The comet was exactly where it was supposed to be, glowing with its characteristic greenish glow, dragging a diffuse tail of dust and ionized gas. But there was something more, a thin structure, almost imperceptible, that extended in a direction that should not exist, a line of light that pointed toward the sun instead of away from it. Robert blinked, adjusted his monitor, verified his calculations. He thought it was an error, an optical artifact caused by some internal reflection in his telescope or a defect in the image processing. But the more he analyzed the data, the clearer the pattern became. That was not an error. It was real. And it was something that, according to everything he knew about cometary physics, simply should not be there. Without wasting time, Robert uploaded his images to an international amateur astronomy forum, a space where enthusiasts from around the world share their observations and discuss them with enthusiasm. He wrote a brief message, almost timid, asking if anyone else had noticed that peculiar structure in 3I Atlas. He did not expect an immediate response. It was 3 in the morning in Chicago. Most American observers would be asleep. But the world is large, and there is always someone awake somewhere. In less than an hour, his post had received dozens of responses. Astronomers from Spain, from Australia, from Japan, from Brazil, all confirming the same thing. They too had seen that structure. They too had wondered what it was, and none of them had a satisfactory explanation. The news began to escalate rapidly. What had started as a casual observation from a backyard in Chicago became the main topic of conversation in astronomical circles. Professional observatories, which until that moment had been focused on other aspects of 3I Atlas, began to pay attention to that anomaly, and what they found left them puzzled.
This is where the story gets truly interesting, friends. Did you know that normal comets develop tails that always point in the opposite direction from the sun? It is a well-understood phenomenon caused by the pressure of solar radiation and the wind of particles that our star constantly emits. But 3I Atlas was doing something different. It was showing what scientists call an anti-tail, a structure that seems to defy the laws of physics. How is it possible for a natural object to do something like that? Are you starting to see why this comet has everyone so unsettled?
To understand why the anti-tail of 3I Atlas is so puzzling, we first need to understand how ordinary comets work. When a comet approaches the Sun, the ices that make up its nucleus begin to sublimate. That is, they pass directly from solid to gaseous state without becoming liquid. This process releases enormous amounts of gas and dust, creating a diffuse atmosphere around the nucleus known as a coma. Solar radiation and particle wind push this material outward, forming the characteristic tails that have fascinated humanity since ancestral times. Comets typically develop two types of tails. The ion tail, composed of ionized gas, always points directly opposite to the Sun, following the lines of the interplanetary magnetic field. The dust tail, formed by heavier particles, curves gently following the comet's orbit. Both structures are predictable, modelable, understandable with the tools of modern physics. An anti-tail, on the other hand, is something completely different. It appears when geometric conditions are very specific, when Earth passes through the comet's orbital plane and we can see heavy dust particles that have lagged behind along its trajectory. From our perspective, these particles seem to form a tail pointing toward the Sun, although in reality, it is simply a perspective effect. It is like looking at a highway from an elevated bridge and seeing how cars going in opposite directions seem to converge toward the same point on the horizon. But here is the problem with 3I Atlas. Its anti-tail does not behave as it should. It is too narrow, too bright, too stable. Physical models predict that an anti-tail should be diffuse, scattered, barely visible. What Robert Chen captured from Chicago and what observatories around the world subsequently confirmed was something completely different. An almost perfect line of light, as if someone had traced a laser beam across millions of kilometers of empty space. Astronomers began to search for explanations. Perhaps the comet's composition was unusual, with ices that sublimated in ways not predicted by standard models. Perhaps magnetic fields were involved, electromagnetic interactions that our theories still did not fully capture. Perhaps the internal structure of the nucleus was so irregular that it produced perfectly directed jets of gas, creating patterns that seemed artificial, but actually had natural causes. Each of these explanations had merit, and scientists worked feverishly to test them. Spectroscopic data were collected to analyze the comet's chemical composition. Computer simulations were performed to model different gas emission scenarios. Observations of 3I Atlas were compared with historical records of other comets that had shown anti-tails. But no explanation fit perfectly with all the observations. Every time they thought they had an answer, new data appeared that did not fit. And while scientists debated the nature of the anti-tail, another anomaly began to emerge from the data, an anomaly even more puzzling, even more difficult to explain.
Friends, here comes the part that personally keeps me awake at night. Do you remember when I told you that 3I Atlas had changed its course in the void? It was not a metaphor, it was not an exaggeration. The most recent calculations show that this comet experienced a trajectory adjustment while passing behind the Sun, invisible from Earth. What type of force can make an object change its course when no one is observing it? What secrets does this interstellar visitor that arrived from the depths of the cosmos hold?
The detection of the trajectory correction was almost accidental. A team of astronomers from Lowell Observatory in Arizona was performing routine calculations to update the predicted orbit of 3I Atlas. This type of work is common in astronomy, especially for new objects that do not yet have an extensive observational history. As more data are collected, predictions are refined, errors are reduced, the trajectory becomes more precise. But when the team compared the observed positions after the comet's passage behind the Sun with the predicted positions before that event, they found a discrepancy. It was not enormous, barely a few tenths of an arc-second, an amount that would be invisible to the naked eye and required instruments of extreme precision to detect. But it was real, consistent, and pointed toward an inescapable conclusion. Something had pushed the comet while it was hidden. The most obvious explanation was outgassing. The jets of gas that comets emit act like small rocket engines, providing a subtle but measurable thrust. It is a well-documented phenomenon, observed in countless comets throughout the history of astronomy. Most unexpected orbital corrections can be explained this way, and there is no reason to suppose that 3I Atlas would be different. But there was a problem. The thrust required to produce the observed deviation was extraordinarily precise. It was not a chaotic and random push, like those typically produced by outgassing. It was a specific adjustment, almost surgical, that had placed the comet on a very particular trajectory. A trajectory that will take it, in March of the year 2026, directly toward the Hill radius of Jupiter. For those unfamiliar with the term, the Hill radius is a fundamental concept in celestial mechanics. It defines the region of space around a planet where its gravity dominates over that of the Sun. Within that radius, objects can be captured into orbit around the planet or experience strong gravitational perturbations. Outside of it, the Sun's influence is predominant. It is an invisible boundary, a limit that separates two different gravitational realms. Jupiter's Hill radius is enormous, approximately 53 million kilometers. It is an invisible sphere surrounding the giant planet, marking the territory where its gravity is supreme. And 3I Atlas, after that mysterious correction, is heading exactly toward the edge of that sphere. Not near it, not in its general proximity, but exactly toward it. The precision of this trajectory is what has astronomers so puzzled. The odds of a random adjustment caused by outgassing producing exactly this result are astronomically low. It is like throwing a dart blindfolded from a kilometer away and hitting exactly the center of the target. Possible in theory, but so improbable that any reasonable person would look for another explanation.
Let me pause here, friends, so that we can reflect together on what we are hearing. Have you ever thrown a stone into water and expected it to change direction on its own? Because that, in essence, is what we are seeing with 3I Atlas, a cosmic rock that seems to have decided midway through to alter its destiny. Is this possible according to the laws of physics we know, or are we facing something that requires completely new explanations?
The theories began to multiply. Some scientists proposed that the composition of 3I Atlas might include exotic ices, volatile compounds that behave in ways not predicted by standard models. Perhaps the comet contained large amounts of frozen molecular hydrogen, a material extremely difficult to detect, but capable of sublimating even at great distances from the Sun. Perhaps there were pockets of solid nitrogen or pure carbon monoxide, substances that could evaporate in unusual ways and produce thrusts more directed than traditional water ices. Other researchers suggested more exotic explanations. Perhaps 3I Atlas was not simply a comet, but the remains of a larger object that had fragmented at some point in its history. Perhaps it contained internal cavities, hollow structures that affected the way gas escaped from the nucleus. Perhaps its shape was so irregular, so different from any comet we had studied before, that its dynamic behavior was completely unpredictable. And then there were the bolder voices, respected scientists who dared to raise possibilities that made many of their colleagues uncomfortable. Professor Abraham Loeb of Harvard University was one of those voices. Loeb is not a marginal theorist or a publicity seeker. He is a serious scientist with hundreds of publications in specialized journals, someone who directed Harvard's Department of Astronomy for nearly a decade. And he had suggested, first with Oumuamua and now with 3I Atlas, that the observed anomalies might have explanations that transcended conventional physics. Loeb did not claim that 3I Atlas was an alien spacecraft. He did not say that there were little gray beings piloting it through the cosmos. What he argued was more subtle, more scientific in a sense. He said that when observations do not fit our models, we have two options. We can adjust the models until they fit, which sometimes requires increasingly elaborate and improbable assumptions, or we can consider the possibility that we are seeing something genuinely new, something that our current theories are simply not equipped to explain. For Loeb, the possibility that some interstellar objects might have artificial origins was not science fiction. It was a legitimate hypothesis that deserved to be investigated with the same rigor as any other. And the anomalies of 3I Atlas, combined with those that had been observed in Oumuamua years before, suggested that perhaps there were patterns worth examining more closely.
Now, friends, before you think I have gone off into the clouds, let me be clear with you. I am not saying that 3I Atlas is an extraterrestrial probe. I have no evidence of that, and no serious scientist does either. What I am saying is that the anomalies are so significant that we cannot close our eyes and pretend that everything is normal. Do you remember Oumuamua, that elongated object that passed through our solar system a few years ago? Well, 3I Atlas is doing very similar things. Is it coincidence, or are we facing a pattern?
Oumuamua had been the first confirmed interstellar visitor in the history of modern astronomy. It appeared without warning in October of the year 2017, detected by the Pan-STARRS telescope in Hawaii. Its name, in Hawaiian, meant approximately messenger from afar arriving first, and it had been an extraordinarily strange messenger. Its shape was unusual, elongated like a cigar, perhaps 10 times longer than it was wide. It showed no visible tail despite passing relatively close to the sun, which suggested it lacked the surface ices typical of comets. And most puzzling of all, it had accelerated as it moved away from the solar system, as if something were pushing it from behind. Astronomers had proposed various explanations for this anomalous acceleration: outgassing of exotic ices that did not produce a visible coma, radiation pressure acting on an unusually thin and reflective surface, thermal effects caused by the object's rotation and its intermittent exposure to solar heat. But none of these explanations had been completely satisfactory, and Oumuamua had disappeared into the darkness of interstellar space before we could study it more thoroughly. Now, with 3I Atlas, the story seemed to be repeating itself. Another interstellar object, another series of inexplicable anomalies, another opportunity to solve cosmic mysteries. But this time, there was a crucial difference. 3I Atlas was brighter, more active, and its trajectory would allow it to remain observable for much longer. We had years to study it, to analyze it, to try to understand what made it so different from ordinary comets. The observations from Chicago had been just the beginning. As the news spread, telescopes around the world began to point toward the interstellar visitor. Observatories in Chile, in Spain, in Australia, in Japan, all collecting data, all trying to capture every possible detail of this enigmatic object. And what they were seeing was fascinating.
Friends, I want you to imagine something for a moment. Imagine that you are looking through a telescope, that you have before your eyes an object that has traveled for millions of years from some remote corner of the galaxy, an object that contains information about places we will never visit, about stars we will never see up close, about cosmic processes we are just beginning to understand. Does it not seem extraordinary to you that we can do that? That from our small planet we can reach, even if only with our gaze, the depths of the universe?
The images coming from different observatories showed an object in constant evolution. The tails of 3I Atlas were not static. They were changing shape, developing new structures almost in real time. There were moments when the anti-tail intensified, becoming brighter and more defined. There were moments when new secondary tails seemed to sprout from the nucleus, ephemeral like steam from a boiling kettle. It was as if the comet were alive, breathing, reacting to the changing conditions of interplanetary space. Spectroscopes revealed a complex chemical composition. There were signals of hydrogen cyanide, a molecule common in comets, but present here in unusual proportions. There were indications of organic compounds, carbon chains that are the fundamental building blocks of life as we know it. And there was something more, spectral signals that did not perfectly match any known compound, absorption and emission lines that scientists were still working to identify. The dust distribution was also anomalous. In a normal comet, we would expect to see a clear separation between fine and coarse particles. Fine particles, being light, are quickly pushed outward by solar radiation pressure, forming an extensive and diffuse tail. Coarse particles, being heavier, remain close to the orbital trajectory, forming a separate band. Over time, this segregation becomes very evident. But in 3I Atlas, this separation was not so clear. There were regions where fine and coarse dust seemed mixed, as if they had been released simultaneously from the same area of the nucleus, but then behaved in different ways. It was a pattern that defied standard models of cometary emission, another mystery to add to the growing list. Robert Chen, the amateur astronomer from Chicago, who had made the first detailed observations of the antitail, had become a small celebrity within the astronomical community. His name appeared in scientific articles as co-discoverer of the anomaly. He received emails from professional researchers asking him for details about his equipment and observation techniques. Journalists from around the world wanted to interview him, to ask him how he felt about having contributed to one of the most intriguing astronomical mysteries of recent times.
And here is something beautiful, friends, something worth highlighting. Astronomy is one of the few sciences where amateurs can make genuinely important contributions. You do not need a doctorate or $1 million observatory. With patience, dedication, and a good telescope, you can be part of great discoveries. How many of you have ever looked through a telescope? How many have felt that deep connection with the cosmos that only direct observation can provide?
As the weeks passed, the scientific focus began to shift toward the future. Specifically, toward March of the year 2026, when 3I Atlas would reach the vicinity of Jupiter. This encounter promised to be a crucial moment in the object's history, a turning point that could reveal fundamental information about its nature. Jupiter is the most massive planet in the solar system, a gas giant with a mass equivalent to more than 300 Earths. Its gravitational field is so intense that it has shaped the architecture of the entire solar system, capturing asteroids, deflecting comets, protecting the inner planets from catastrophic impacts. Any object that passes near Jupiter experiences enormous gravitational forces, forces capable of altering trajectories, fragmenting weak nuclei, even capturing objects into permanent orbits around the planet. The fact that 3I Atlas was heading exactly toward Jupiter's hill radius raised fascinating questions. What would happen when the comet entered that zone of gravitational influence? Would it show signs of fragmentation under Jupiter's tides? Would it experience changes in its activity as it approached the planet? Or would it pass through the region without incident, continuing its journey toward the depths of interstellar space? Scientists were divided in their predictions. Some expected the encounter with Jupiter to reveal the internal structure of the nucleus, causing fragmentations that would expose fresh, pristine materials that had never seen sunlight. Others anticipated that the planet's gravity would alter gas emission patterns, creating completely new structures in the tails and antitail. And there were those who feared that the comet might completely disintegrate, destroying in the process our opportunity to study it in detail. But there was also another possibility, one that the more daring scientists dared to mention only in private conversations. If 3I Atlas was something more than a natural comet, if there was any truth to the speculations about possible artificial origins, then the encounter with Jupiter might reveal completely unexpected behaviors, deliberate maneuvers, trajectory adjustments, signs of some type of intelligence or design behind its movement.
I know what you are thinking, friends. Felipe, this sounds like science fiction, and you are right, it does sound like that. But let me remind you of something important. Yesterday's science fiction is frequently today's science. A century ago, the idea of detecting gravitational waves was fantasy. 50 years ago, discovering planets around other stars seemed impossible. Why should we assume that we already know everything? Why close doors before we have even looked through them?
While scientists debated and speculated, observations continued to accumulate. Every night, dozens of telescopes pointed toward 3I Atlas, capturing images, measuring spectra, recording brightness variations. The amount of data was overwhelming, and processing it required the combined effort of institutions from around the world. And from that analysis, new details began to emerge, each more intriguing than the last. The comet's brightness variations did not follow the expected pattern. Normally, when a comet rotates, its brightness varies predictably as different regions of its surface become exposed to the sun. It is like watching a colored ball spin under a lamp. The tones change in a regular and repetitive cycle. But 3I Atlas showed variations that did not correlate with any simple rotation period. There were brightness peaks that appeared and disappeared without obvious reason, fluctuations that seemed random but, when analyzed statistically, showed subtle patterns. Some researchers proposed that the nucleus might be in a state of chaotic rotation, spinning in complex and unpredictable ways. This type of motion is possible for objects with very irregular shapes and would explain the apparently erratic variations in brightness. But others pointed out that even chaotic rotation should produce patterns that could be modeled mathematically. And the data from 3I Atlas resisted all attempts at fitting. The fine structures within the tails were equally puzzling. There were thin filaments of material that seemed to remain coherent for surprisingly long periods, resisting the dispersion that would normally affect such structures. There were regions of unusually high density within the coma, as if there were point sources of emission at specific locations on the nucleus. And there was, of course, the persistent anti-tail, that line of light that continued to defy conventional explanations.
Here I want to pause to reflect with you, friends. Think about what all this means. An object that comes from outside our solar system that shows behaviors we do not understand, that is heading toward a precise encounter with the largest planet we have. Does it not seem to you that the universe is sending us some type of message? That there is something out there waiting to be discovered, waiting for us to be curious and bold enough to look for it?
The relationship between 3I Atlas and Jupiter had historical precedents that added additional layers of intrigue. Oumuamua, the first confirmed interstellar visitor, had also interacted with the gas giant. Its trajectory had taken it to pass near Jupiter's orbit, although not as close as the one 3I Atlas would follow. Some astronomers had speculated that Oumuamua might have used Jupiter's gravity to accelerate its exit from the solar system, a maneuver known as gravitational assist that our own space probes have used repeatedly. If two consecutive interstellar visitors had had significant encounters with Jupiter, was this simply coincidence? Probably yes, from a strictly statistical point of view. Jupiter is the most massive planet in the solar system, and its gravitational influence is so great that it affects almost any object passing through the inner regions of our cosmic neighborhood. It was natural for interstellar visitors to interact with it in some way, but there was something in the pattern that troubled some observers. Two objects, with completely independent origins, formed in different places in the galaxy, following trajectories that led them to similar encounters with the same planet. Was it pure chance, or was there some underlying factor we were not considering? Some theorists proposed that there might be an observational bias at play. Perhaps we preferentially detect interstellar objects that pass near Jupiter, because those objects tend to be deflected toward the inner regions of the solar system, where they are easier to observe. In that case, it would not be surprising that all our known interstellar visitors had some connection to the gas giant. But others argued that this explanation was not completely satisfactory. The trajectories of Oumuamua and 3I Atlas were too specific, too precise, to be explained solely by detection biases. There was something more at play, something we still did not fully understand.
Friends, let me share something personal with you. When I was a child, I used to spend nights looking at the stars from the roof of my grandparents' house in the countryside. I wondered what was up there, if there might be other beings looking toward us with the same questions. I never imagined that decades later I would be telling you about objects that literally come from other stellar systems. The universe, friends, never stops surprising us. Does it not seem amazing to you?
As 3i Atlas continued its journey toward the interior of the solar system, observations became increasingly detailed. The largest telescopes in the world, equipped with adaptive optics and state-of-the-art detectors, were producing images of unprecedented resolution. And what they showed was an object in constant transformation. The comet's nucleus appeared to be active in unusual ways. There were regions that emitted gas continuously, creating persistent jets that propelled material into space. There were other regions that seemed completely inactive, dark and silent like dead rock. And there were intermediate zones where activity fluctuated, turning on and off in cycles that did not correspond to any obvious pattern of solar illumination. Spectroscopes revealed changes in the composition of emitted material. At some moments, emissions were dominated by carbon and nitrogen compounds. At others, signals of silicates and metals appeared, as if deeper layers of the nucleus were becoming exposed. And occasionally, there were spectroscopic flashes that scientists could not identify, emission lines that did not correspond to any known element under expected conditions. Did this mean that 3i Atlas was made of completely different materials from those in our solar system? It was a very real possibility. The comet had formed somewhere in the galaxy, probably around a star very different from the Sun. The conditions of temperature, pressure, and chemical composition at that place of origin would have been different, and the resulting object would reflect those differences. If 3i Atlas contained types of ice we had never studied, organic compounds that do not exist on Earth, crystalline structures that sublimated in completely unexpected ways, then its anomalous behavior would have a natural explanation. It would simply be the manifestation of strange chemistry, different from anything we knew, but perfectly consistent with the laws of physics.
But here is the uncomfortable question, friends, the one we are all thinking but few dare to formulate out loud. What if it is not strange chemistry? What if it is not unknown physics? What if we are seeing something that was designed? I am not saying that it is so, understand me well. I am only saying that the possibility exists and that ignoring it would be scientifically irresponsible. Do you not think we should keep an open mind?
The question of extraterrestrial intelligence had long been a taboo subject in serious scientific circles. Mentioning it at an academic conference was risking one's reputation and credibility. Scientists who dared to explore this possibility were frequently marginalized, accused of seeking publicity, or of abandoning the principles of scientific rigor. But in recent years, attitudes had begun to change. The discovery of thousands of exoplanets, worlds orbiting other stars, had demonstrated that planetary systems were common in the galaxy. Some of those worlds were inhabitable zones, at distances from their stars where liquid water could exist on the surface. The idea that life might exist elsewhere in the universe had ceased to be speculation and had become a legitimate scientific hypothesis. And if life could exist elsewhere, then intelligence could also have evolved. There was no fundamental reason to suppose that humans were unique in the cosmos, that the spark of consciousness had only ignited once in the entire history of the universe. If there were other civilizations out there, some of them might be much older than ours, with technologies we could not even imagine. Could those civilizations send probes across the galaxy? It was a possibility worth considering. After all, we ourselves had launched the Voyager probes, which would eventually leave the solar system and wander through interstellar space for millions of years. If other civilizations did the same, the space between the stars might be full of traveling artifacts, relics of cultures that perhaps no longer existed. 3i Atlas, with all its anomalies, fit uncomfortably well into this speculative scenario. Its precise trajectory toward Jupiter's Hill radius could be the result of deliberate programming, a flight plan established eons ago by unknown builders. Its anomalous anti-tail could be some type of propulsion or communication system we did not recognize. Its erratic brightness variations could be signals, attempts at contact we were not interpreting correctly.
And that brings me to something I want to share with you, friends. We can all be part of this. You do not need a university degree or a sophisticated laboratory. You only need curiosity and a desire to look upward. The universe is there, waiting to be observed, waiting to be understood. Would you not like to be part of that adventure? Do you not feel that call that has accompanied us since our ancestors first looked at the stars?
And so, somewhere among the stars, a mysterious object continues its silent journey. It comes from a place we will never know. It goes toward a destination we can barely imagine. But for a brief cosmic moment, its path crosses ours, giving us the opportunity to look at it, study it, wonder what it is and where it comes from. It is a gift from the universe, an invitation to curiosity, a reminder that there are still wonders to discover. And as long as we keep accepting that invitation, as long as we keep looking upward with eyes full of wonder, the cosmos will continue to reveal its secrets to us, one by one, flash by flash, star by star. Until we meet again under the same night sky, until another cosmic story brings us together in this space of shared curiosity, keep your gaze on the stars, because up there, among the lights that flicker in the darkness, there are mysteries waiting to be discovered, and one of them, a visitor called Three-Eye Atlas, is coming toward us.
Before I say goodbye, friends, I want to ask you something. If this story made you think, if it made you wonder, if it made you feel that spark of wonder that we all carry inside, I invite you to subscribe to the channel. There are many more stories like this waiting to be told, many more cosmic mysteries to explore together, and I would love for you to accompany me on that journey. Leave me a comment. Tell me which part of this story reminded you of something from your own life. Maybe it was a night under the stars, maybe it was a moment of childhood wonder, maybe it was simply that feeling that there is something greater than us, waiting for us out there. Share your experiences with me, because deep down we are all travelers in this immense cosmos, all looking at the same stars, all wondering the same things. Until next time, friends, may the sky be with you.